Let's understand HDFS blocks in this video. In Hadoop, data is stored in HDFS, that's Hadoop Distributed File System. Hadoop is also known for its efficient and reliable storage technique. Let's understand how Hadoop is making its storage so much efficient and reliable. So Hadoop HDFS splits large files into small chunks known as blocks. Block is the physical representation of data. It contains a minimum amount of data that can be read or written. HDFS stores each file as blocks. Let's discuss this with an example. So when you import any file to HDFS, it gets divided into blocks of some size, and then these blocks are stored on slave nodes. This is a kind of normal thing that happens in almost all types of file systems. By default in Hadoop 1, these blocks are 64 MB in size, and in Hadoop 2, these blocks are 128 MB in size, which means that all the blocks that are obtained after dividing a file should be 64 MB or 128 MB in size. Manually change the size of the file block in hdfs site.xml file. So let's say that we want to store a file with a size of 1000 MB on HDFS. So take a while to think how many blocks will be created for this file in Hadoop 2. Think about it for a second. This file will be divided into 8 blocks. 7 blocks comprise of 896 MB, where each block of 128 MB is there, and remaining 104 will go to the 8th block. And you can see here that 128 into 7 plus 104 adds up to 1000 MB. Now you might be wondering, why is the file size so big in Hadoop? What is going on here? Well, note here that the file size is quite large as compared to Linux OS, which has a block size of 4 KB. Hadoop is designed to store very large volume of data from terabytes to petabytes. That makes it different from other file systems as it can be scaled very easily. Let's see a few of the merits of having a large file size. Blocks are made bigger so that we can minimize the cost of seeking or finding, because sometimes time taken to transfer the data can be more than the time taken to start these blocks. A quick calculation shows that if the seek time is around 10 milliseconds and the transfer rate is 100 Mbps, to make the seek time 1% of the transfer time, we need to make the block size around 100 MB. The default is actually 128 MB, although many HDFS installations use larger block sizes. Secondly, making the unit of abstraction a block rather than a file simplifies the storage subsystem. Simplicity is something to strive for in all systems, but it's especially important for a distributed system in which the failure nodes are so varied. The storage subsystem deals with blocks, simplifying storage management. Because blocks are a fixed size, it's easy to calculate how many can be stored on a given disk, and eliminating metadata concerns, because blocks are just chunks of data to be stored, and file metadata such as permission information does not need to be stored with the blocks. So another system can handle metadata separately. Furthermore, blocks fit well with replication for providing fault tolerance and availability. To ensure against corrupted blocks and disk and machine failure, each block is replicated to a small number of physically separate machines, typically 3. If a block becomes unavailable, a copy can be read from another location in a way that is transparent to the client. A block that is no longer available due to corruption or machine failure can be replicated from its alternative locations to other live machines to bring the replication factor back to the normal level. We'll see more about replication in the next video. So that's it for now. I'll see you in the next video. Thank you.